yeah, I get the dubious honor of doing this talk, because basically they're telling me you didn't make the cut for speaker, but when we've exhausted all other options, welcome to the stage. And you were probably all expecting to hear about awesome, cool machine learning stuff by Michał, and I'm not smart enough for that. So I'm going to try to dazzle you with solid principles. And I hear this sigh going through the audience going, oh, not again. Okay. But first of all, who am I? So my name is Klug. I do work at 1337. I have a weird position. I do work as a developer, but I also spend probably way too much of my time standing on stages around the world talking about different things, different software development stuff, and trying to spread and share the knowledge that I've learned over time. And it kind of goes pretty well hand in hand with working at 1337, that we try to share knowledge and help other people get up on new stuff as well. So I have a weird mixed background, mostly Microsoft stuff, and I don't have a computer science degree. So how many people in the room have a computer science degree of some sort? Yep. Okay. Ever heard of imposter syndrome? So there are certain things that you kind of miss out on. And a few years ago, I decided that I'm going to learn the solid principles, because everybody talks about the solid principles, right? So we're going to, before I get started talking about what they are, how they work, why they're important, and all of the good stuff, I want to do some nerd gymnastics. You're the nerds, you're going to do gymnastics, I'm going to tell you what to do. I'm going to ask you to raise your hand when you say, for my questions, and I want you to keep your hands up, because I want to see hands go down over time. And if it gets too heavy for you to hold up one hand, you are allowed to switch to the other hand. If that is too heavy, you go back to the other one. If it's too heavy, I suggest hitting the gym once in a while. So, how many of you have heard about the solid principles? Hands up. That should be pretty much everyone. This is when I just want to pause and sit here and just wait for you to go, I'm not going to do that. So, how many of you can name all the 5 principles? So this is in no way a scientific way of measuring anything, but I've asked this question probably 30, 40 times around the world, and the response is always the same, which is interesting. So what I want to see if this response is the same for the last question as well, because keep your hands up. How many of you can explain Liskov Substitution principle? And there it is, we've got 2 hands. This works in every audience in the entire world, no matter how big the stage is. Because you start out asking, how many have heard about it? And you'll get pretty much 98% of the audience will say yes. And then you say, can you name it? And it drops down to sort of 50%-ish. And then you ask them to explain Liskov's, and basically all hands except 2 hands disappear. And then if it hadn't been for the fact that Martin was one of the people holding up his hand, I would have said that the person with the hand up could come up and explain on stage, and then that hand goes away as well. So what I want to do is I want to walk through the different principles, why they're interesting, what they mean, and how they work. But to do that, I've tried to write a little application where I can show you the solid principles one step at a time. Bear in mind that when I pull up this app, you're going to look at it and you're going to go, that is the worst developer I've ever seen. Very possible. And it's also, that is the most stupid program I have ever seen. Once again, very possible. But try going home and writing a little application that can show off all the solid principles step by step in an application that is small enough to understand in 3 minutes, but complex enough to actually be able to use all the principles. That is why my application is shit. Pardon my Swedish. So what I've built is a little application here that converts formats. So it's a very simple thing. It's a console app, because that's kind of what I build nowadays. And it has a main method, and it takes a source file, which is basically the address for a file. And if we look at the file name, you see that the file name is an XML file. It has a target file name, which is a JSON file. So what this application does is it converts XML to JSON. Nobody wants XML anymore, right? So it reads all the information here from the input file. It creates an X document by doing xdocument.parse. It takes the information from the X document and puts it into an entity called document, which, if you're interested, for some reason navigation doesn't work in this project, is really complex. They said we were going to melt your brains, so I stepped it up a bit, especially after Will's session this morning. it takes that document and it uses JSON.NET to serialize it to JSON, and it stores it back down to disk again as a JSON file. How many of you have built an application like this before? Quite a few. Okay. Did it look something like this? Pretty much, because nobody would ever go and make this more complicated, which is what I'm going to do for the rest of the session. So this is actually the way I do a lot of my software development. I start out with what I call a RAG implementation, rough as guts. It starts out looking like crap, and I make sure that it works, and then I start splitting it out. So my first step in this case was I split this thing into a slightly more readable application. So if we outline that, you'll see that the main is now basically just split into the different things that is going on in there. It has get input, get document, serialize document, and persist document. Has nothing at all whatsoever to do with the solid principles. It just looks better like that. And also, if you just collapse everything, my code isn't as bad. So that is the application that I'm going to be talking about. And I'm going to walk through that and have a look at the different principles and how we can put those into that application. So for those of you who couldn't name the principles, these are the principles. So the S stands for single responsibility principle. The O stands for open-close principle. L is for Liskov Substitution principle. I is for interface segregation principle. And D is for dependency inversion principle. Very important thing, that last one is dependency inversion principle, not dependency injection principle, which I hear quite a lot. Two different things. Or rather, one is a technology to do one of the principles. So I'm going to start out by looking at single responsibility. That should be the simplest one, right? And we look at the definition of this. I Googled this a bit, and this is kind of what I came up with. A class should only have one reason to change. Makes sense, right? Pretty much. So what is a reason to change? So one reason to change can be pretty big. Like, okay, so a reason for this to change was that my requirements changed. That is one reason, right? So if I just put that in as a reason, I can put whatever I want in one class, because I'll just blame the product owner. He is one reason. We have to define it a little bit better than that for me. I can't just go and say, the only reason for my class to change is the product owner is a moron. It's not a valid reason. So a better definition of single responsibility is there can be only one requirement that when changed will cause a class to change. So we actually have to step back from our code and step back from writing C# or whatever language you're using and start looking at requirements, which is really boring. But you should look at all of your requirements and make sure that there's only one requirement that can ever affect one class. Which is quite interesting because it means that it's really hard to reuse your idea of single responsibility across projects, because even if you're writing the exact same thing multiple times for different clients, the requirements might actually be different. My little application could potentially look single responsible, not really, but it could be fairly okay in one case, but fairly crap in another case. So everything goes back to your current situation. There's none of these, we can just reuse this and it works like a silver bullet for it. But that also means, which I do remember, that when we develop, right, when you sit down at your desk and you pull up your keyboard and you start coding, you all have a very precise specification, right? Everything is well defined. There are no changes. It's like, here is the spec of what you're building. That is kind of what we're doing, right? No. I know. You're all doing agile, which means basically there's no specification and we just hack away and then it becomes really hard. We need specifications and we need to have requirements for this to work. And then I have another question, just that I like for my own sanity check as well. I learned programming saying that nouns are classes, verbs are their functions, and adjectives are their properties. Has anyone else heard that? Few people? Yeah, you can screw that. You can just throw out the book on that, because that's not going to work. That works well if you're building a domain-driven design solution, and you're building a domain model where your classes are trying to replicate the world. If you're trying to be solid, it's really, really hard, because the requirements will intermingle into your classes if you do it like that. So initially, at least, you're going to have to forget this idea and start doing development in a slightly different way. So if we have a look at the code that I'm writing, and we look at what I would do for it to make it single responsible, it looks like this. I have my program again. I've got my main method. The program class is single responsible. The only ish. Take it with a grain of salt. Somebody's going to say, no, it's not. Well, it's fairly single responsible. And the only responsibility it's supposed to have is basically hosting my application. So the only thing that can change here is that my product owner comes and says, I don't want a console app. I want to run it as a Silverlight app. That's not going to happen, but I can at least try. That makes this single responsible, and then that news up a format converter. If we're going to look at the format converter object, that thing is also fairly single responsible. It's going to get better. There are a few issues in here, but it has a method called convert format. It basically makes sure that the code is going in the flow that it's supposed to. So it says you start out by reading the data, then you go on and you parse it, and then you serialize it, and then you persist it. So the only reason for this class to ever change is if we change the flow of our application. So if I need to change and do something in between, I need to add validation, this is the class that gets changed. It doesn't have any logic around any of the other parts. And then basically just break everything down. Document storage, same thing there, very simple. It has all of the system I/O stuff, so basically reading and writing disk. Only reason this would change, somebody goes and says, you're not going to be storing stuff on disk anymore, you're going to store it in the cloud. Another requirement, single requirement. And basically I just go through that. Input parser, very simple, uses XDocument. Only reason for this to change, I'm not doing XML anymore. But my favorite one is actually document serializer, because this is where people tend to think that I am nuts. Who of you would go and write a class like this? Actually, a few. I like this. How many of you look at this and go, nope? More than the people who did it. And I assume that the people going, nope, are the people that are going to say that why in the world would I have a document serializer called JSON convert.serializeObject in here instead of just adding JSON convert.serializeObject in this line here? For the very simple reason that you're now introducing a second dependency or a second requirement. If somebody comes and says, I'm not going to do JSON serialization, I'm going to serialize to, I don't know, BSON instead. Then all of a sudden, there are two requirements that can make this class change. So by moving it in, even though I'm just doing one single line of code inside of a C# class, I'm isolating the format converter from the serialization, allowing me to be more flexible in the future without going back and changing that thing. So from a single responsible situation, do not go ahead and call JSON convert all over the place, because you are tying yourself into that, and that is a requirement that might change. Does that make sense for those of you who actually don't do this? I can also be, so I'm a quite honest person. So if I'm going to be really honest, I don't write it like that either. But it looks good on stage. The thing is, when you're doing this on stage, you obviously have to draw a line, and it's going to be way more or way less pragmatic than I would normally do it. But it's kind of showing that this is why you do it. But if you now know that I've explained to you that doing it with JSON convert inside of your code, if you decide not to do it, it's a conscious choice. If you don't know that you're doing it or you're doing it without knowing this, it's an unconscious choice, and that causes problems. And then edge cases, and every time I pull up this slide, I go, why did I choose repositories? And I don't know. But repositories are one of those things that we build, right? They access and store data. That should be fairly single responsible, right? Because it's the only thing it does is basically connect to the database, get the data, get back an object, and when you persist it, it takes the object and stores it in the database. That might be single responsible if you are reading and writing to the same data store, and you know that you're always going to be reading and writing to the same data store. So if both reads and writes go to a SQL database, then it's single responsible. If you go and split it out and say, I'm going to have some form of eventual consistency model with messaging and things like that, I might end up writing to a message stream or a message bus, and I might be reading from a blob storage. In that scenario, it's not single responsible. So a repository in that case is not single responsible for read and write, and you end up having to split it because you have two different requirements. So what are the benefits of doing this? Well, the smaller the code, the less likely you are to screw up. And I'm going to say it because you are screwing up. You're all screwing up. We are all screwing up. As a field, we are immensely good at screwing up. But doing it in smaller chunks makes it less likely for us to take a complex thing and screw it up because we don't understand it. If we break it into small pieces and take one little chunk at a time, we're less likely to screw up. Example, is anybody in this room likely to screw up my one-liner method that calls JSON convert.serialize? Nope. So the smaller the pieces, the less likely we are to screw up. And that then brings us nicely into open-close principles. So I kind of like the solid principles because if you go from left to right for me is that for you is, yeah, anyhow. They kind of build upon each other. So once you've done your single responsibility and you've decided that you have really small classes, you get lots of small classes, open-close kind of builds on top of that and says, okay, so we also don't want you to introduce bugs by changing your classes all the time. So open-close principle has this definition that says software entities should be open for extension but closed for modification. They're basically saying once you've built a class, you're allowed to extend it. You can make it better, you can make it bigger, but you can never modify it. So you can never take a class and change it in such a way that you're changing the intended use of it. If you need to change an implementation of a class, you don't change the class, you create a new class. By creating new stuff instead of changing old, you're not going to introduce bugs in working code, you're going to be creating new bugs in new code. So you can always go back to the old implementation that actually works. So deal with that means that we're supposed to write code that we can make better without changing it. I like that kind of code. It's really hard to write though. So I like this definition much more. Once you define a class as being done, it is done. You stop touching it. It has some really interesting side effects. How many of you are doing TDD? For real. Oh, I love that. I'm going to do that in the future. I'm going to add for real, and like 90% of the hands go down. Okay, how many of you have a big set of tests? Say a couple of thousand tests. Does it take a while to run those tests? Do you like sitting there looking at the spinning icon as it runs the tests? Nope. With open-close, it's kind of interesting because you can turn off your tests. You write the test, you verify the test, you verify that your code works as intended. Once the class is done, you can turn off those tests because you're never modifying that code again. So as long as you're doing unit tests, those tests never have to run again. But as soon as you start going in and mucking about with it, you need to re-enable those tests and start running those tests again, which is what you're not supposed to be doing. Once you've done testing it and it's performing as it should, you should be done with it and you wouldn't need to run those tests, basically. And open-close comes in two forms. It comes in the form of Meyer and polymorphic. So Meyer is a guy called Bertrand Meyer. He's probably a very smart French guy a while back. And he came up with this idea of open-close principle to solve some problems. However, his definition of open-close principle was you create a class, and once you're done with your class, you can inherit that class. So you have base classes, or you make it into a base class, and you create a new version of it. And in that new version of that class, or the inherited version, you can extend the class, obviously, because you can just add new features to it. You can add stuff, but you can't overwrite stuff, right? So unless anything is in C# virtual, you can only do what he's saying. You can only extend it, because you can't go in and modify it. So by enforcing the idea of inheriting a class, you can basically force the user to only extend and make it better without touching the old code, or make conscious choices in the base class and say, this method is virtual and this method is virtual, but making sure that you only make methods virtual that you can ensure cannot modify the functionality of the original class. The reason for this was that when Bertrand Meyer was around, they didn't have interfaces. So when we introduce interfaces, people start doing what is called polymorphic implementation, or polymorphic open-close, which is the opposite way around. Because he is saying, here is a base functionality and you can extend that and add more to it. With polymorphic, we're saying, here's an interface. So I'm defining the interface that you're going to implement, but the functionality is going to be out of scope. So instead of taking his approach of saying, it will always have a base set of functionality that you can extend and make or add stuff to, With polymorphic, we're saying here is an interface that you have to adhere to, but you don't necessarily have to inherit any class or anything like that. So the implementation behind that interface can be whatever you want, but it's still the idea of here is an interface and you build it, and then once it's done, and then if you need to make changes to it, you need it to do other stuff, you create a new implementation of that interface. So it's still going open close, saying once it's done, you don't do it again. Does that make sense? Ish? So what can we do with that? Well, I've made some changes to my code, and we'll see if I can figure out what I've made to this code. If we look at the program still looks pretty much the same, except for the fact that you can see that I've added a new source file and a new target file thing in here. And in this case, we can see the target file here being a blob.core.windows. So it's basically a blob storage in Azure. So if we look at storage, which I've obviously made some changes to, here is the version of Meyer, but in an ugly way. So it's kind of almost polymorphic in the way that my base class is completely pure abstract. But it basically defines the functionality, and then I inherit that base class, and I have a file document storage version, which stores to file. But instead of adding functionality, because what I could have done inside of this code is I could have gone in and added an if statement and say, if the file name is this and this, then it should go to this thing. Or I could have added another parameter to my save method or whatever. But instead of adding logic in here to figure out the other implementation, I've gone ahead and I've created a blob document storage. Blob document storage inherits from document storage, implements it using blob storage instead. And finally, just for fun, I created one called HTTP input retriever, which allows me to get files off HTTP instead of getting them off a file stream. But there are some issues with that because it's kind of hard to persist things to HTTP generically. You can't really go and say, can you please save this document to google.com/mydocument.pdf? The web doesn't quite work like that. So that's why this thing is failing, so I have to throw something in here. But this is kind of cool because I get all of these different implementations now, and they could have been different versions, that's one version, or they can be different functionality. So if we go in and look at my format converter, I've added this little thing here at the bottom that's called get document storage for file name. And in here, for now, I have some logic saying, oh, if it's a blob storage URL that you're trying to use, then get one of these. If it's a starts with HTTP, use one of these, and otherwise use this thing here. This is going to disappear, I promise, in the future. But for now, it means that I can actually go in and change the functionality of my format converter and add new functionality without making any changes to this code in here at all, except for the retrieval of my storage implementation. And also, I don't end up making things that cause problems. You remember how I asked you if it was possible to make a mistake in my document serializer, the JSON.NET, the JSON convert.serialize? I managed to make a mistake. It is possible to make mistakes even in really simple code, and I'm not kidding you. This is an official, I did make a mistake doing this, but decided I'm going to include that because it shows something off. So if we look at the document serializer, I have now created an interface for iDocument serializer. It has a very simple method. It takes a document, returns a string. Very, very simple. Here is my original implementation. And when I ran this, because at some point this code actually was compilable and did run, I ended up seeing that all of my JSON was Pascal casing. And if you've ever been on the web and you have issues like I do, if you see JSON and it's Pascal formatted, you get the creeps. So I ended up going, oh, it needs to be camel case. But that's another one. Instead of going into this method here and adding my camel casing formatting here, because it is open close, I don't modify stuff, I add new stuff. So instead of modifying this implementation here, I went and created a new implementation with that change that I needed, and I call it camel case JSON serializer. And then I can sort of inject that into my application, and I get that new functionality. And if I were to introduce something that doesn't work, I can always roll back, or I can reuse the old one. In some cases, maybe I want Pascal. In some cases, I want camel case. I get a bit of flexibility. So open close is kind of an interesting, but also, to be perfectly honest, quite hard thing to implement, because it does add some interesting questions. So it adds these questions: how do I know what means changing and what means extending and modifying? So extending is quite easy if you're doing, or it's rather, in the Meyer case, it's kind of simple. You don't change the class, you inherit and you add new functionality to it. But then the question comes, how much of my class that I build should I make virtual? Because I'm allowed to make stuff virtual in my class so that inheriting classes in the future can modify the functionality by overriding methods, but I shouldn't make classes or methods virtual to the degree that I can change the functionality of the base class outside of the parameter of what it was supposed to be doing. But with Meyer, it's easy because I can extend it, because I can add other functionality, so I can add new functions to it to my interface. In the interface situation, or polymorphic, we have another question, and that is, okay, so in that case, where do I draw the line of, who defines what the interface should actually do? So when you have a base class, the base class sets the tone. It says that this is what it's supposed to be doing. If you have an interface, nobody's actually telling you what that interface should be doing. You're going to hopefully give it a name, right? But I could name my interface IA, or iInterface, or whatever you want. Completely useless. And the method could be called method 1. Nobody has any clue of what method 1 does, so when you create a new implementation of it, you don't know if you're changing the intended functionality or not. So it gets a bit murky. And then obviously, you are allowed to change your code if you find bugs. So if you have production code out there running and you're doing open close and somebody comes and finds a bug in your code, you're obviously allowed to go in and fix bugs, but that's about it. You're not supposed to go back and add functionality. So what are the benefits of this? Well, I have learned over my almost 20 years in this business that clients dislike when you pull down their production systems. They kind of dislike when you do deployment and their application blows up. With this in mind, you're hopefully going to have less blowouts, because you're not changing functionality, you're adding stuff, and it means that you're not introducing bugs in existing stuff. You're hopefully thinking through how you build new things and you create new versions. And if you ever end up creating a new version that doesn't work, you can always roll back because you have a version that worked before, for example. And basically, it should, in theory, remove regression bugs in your units. Next one is Liskov Substitution principle, which is my favorite-ish, because it's the one that brings everybody's hands down. Makes me feel smart. Is there anybody want to try to define what Liskov means, or what it says? The definition is here. Let Qx be a property provable about objects x of type T, then Qy should be provable for objects y of type S, where S is a subtype of T. That is quite obvious, right? Just for a second, does anybody understand this? Because I did show this at one point, and one guy went, "Yes, it's obvious," and I'm like, "What?" He taught math at university in the US, so he looked at that and went, "That's quite obvious," and not to me. I have a hard time understanding this, and I'm pretty sure that when Barbara Liskov presented it, if she showed that slide, they probably would have gone, "What?" What she is saying, if we take away that and we add a human-readable version of it, what it's saying is a subclass should behave in such a way that it will not cause problems when used instead of a superclass. That makes a bit more sense to me. What she's saying is that if you're doing single responsibility, open close, that's going to end up with you creating new instances all the time. So you're going to be passing in subclasses in places of other classes, or superclasses. So it's going to mean that you're going to have all of these new classes being floating around. So you need to make sure that when you create a subclass or create a new implementation of an interface, that implementation does not break existing code. So if you introduce certain features in your new code, then you might be breaking existing code because the existing code doesn't know that things can happen. The good thing about this is that she was nice enough to come out and give us rules. The rules are: contravariance of method arguments in a subclass are allowed, and covariance of return types in a subclass is allowed. Anybody not 100% sure what contravariance and covariance means? Thank you. What it means, if we put this in normal human-readable terms, it says that if you're inheriting a class or implementing a new interface, that new interface is allowed to define a method with more specific arguments than, less specific arguments, other way around, less specific arguments than the base class. So if you have a base class that takes in sports cars, you are allowed to create a new version of that interface, or inherit from that class, or create a new version of that interface, and let that implementation accept cars. Why? Well, for the very simple reason that any running system knows that I'm allowed to pass in sports cars. So if you give it another implementation that only that accepts cars, it's going to be happy that the existing code passes in sports cars. It doesn't matter because car is more generic than a sports car. If you went the other way around, you would break existing code, right? If you have code out there that passes in cars to a class, and you all of a sudden put a class in place that only accepts sports cars, it would blow up in some cases, probably. And covariance of return types is the other way around. So when you're returning things from a method, you can change the return type from being one type to a more specific type, or a subtype of what the base class returned. So if the base class returned sports car or a car, you're allowed to return sports car. So as long as you go more specific than the base class, it is fine, because once again, any running code out there will expect to get a car back. If you return a sports car, that code is going to be happy. Does that make sense? And that brings me to the question, how many of you people are working with C# mainly? And how many of you are using Java mainly? For all of you people, you can ignore this rule because it's impossible to break. The language will not allow you to break this principle because you cannot change the parameter types or the return types of a method in C# and Java and a lot of other languages. So you cannot break it. And trust me, I have tried. I have spent a good afternoon going through dynamics and stuff like that to break this. The language and the compiler will stop you. So that's kind of fine. The next rule is you are not allowed to throw new exception types unless the new exceptions inherit from exception types that was thrown before. Once again, quite obvious. If existing code is running through your application, you put in a new class, and all of a sudden you're throwing new exception types. There is no way for the existing application to be able to handle those types, right? But if we do throw exception types that are inheriting from other exception types that is known, they will be caught by catch clauses and things like that because they are subtypes of existingly or well-known types. There's a way around this, and that means that when you write your first implementation, always throw just an exception, which is the base class of every single exception. You're open to throw whatever you want after that. If you ever do that, I will kill you. No, sorry, I will hunt you down when you sleep like Freddy Krueger and kill you in your sleep. Don't do that. Throw as specific exceptions as you possibly can, but this thing is to make sure that when you put your new class in there, you're not basically killing your system by throwing a new type. And then there is the preconditions cannot be strengthened in a subtype and postconditions cannot be weakened in a subtype. That basically says that you cannot all of a sudden add new requirements. So you can't all of a sudden say, this thing you used to be able to do before, you're not allowed to do that anymore. And you cannot go and say that thing you weren't allowed to do before, you're now allowed to do. Basically, you need to keep that in mind. So if you're adding a new class and all of a sudden you make some changes saying that previously you could call this method, that was fine, but all of a sudden with this new version you can only call this method if you have set this property over here, or you can only call this method with this argument, then you've added a condition to it, which means that existing code might fail. So keep in mind, new implementations, you cannot add and change the preconditions and postconditions of your class. And the final one is the history constraint. The history constraint is the easiest one. It basically says if you're building an immutable object and you inherit that, you're not allowed to change it from immutable to mutable. If you're building a mutable object, you're not allowed to change it from mutable to immutable in your new version. So that's kind of easy to remember. It's not very complicated. Everybody okay with Liskovs? Everybody thinking, that is really nothing I really care about and I'm not going to think about that when I get back home? Most of these are things you're going to figure out on your own. Most of these are not hard to grasp. Most of these are quite easy to grasp and you do get them after a little while, but it's good to know that there's like defined rules. If you stick to these, it will work. I usually demo a set of my code that uses Liskovs, but I've decided not to do that because that code is even worse than the one that I've shown you so far, because I couldn't get Liskovs into my application, and the new examples were just terrible. It's really hard to show off really good Liskovs implementation. I think the only one that everybody knows, or people who have read this knows about, is square and rectangle. How many have heard the story of square and rectangle? Okay, so for those of you who haven't heard it, you're building an application that works with geometric figures. You're going to build a square and you're going to build a rectangle. Two different objects. Should the square inherit from rectangle or should the rectangle inherit from square? Let's do a show of hands. How many think that the square should inherit from rectangle? Okay. How many of you think that the rectangle should inherit from square? And the best thing is that you're all wrong, because they cannot inherit from each other. There's no way, because you would be breaching Liskovs, because you would either weaken or strengthen your conditions. So if you've got a rectangle can have different lengths of their sides, right? So width and height can be different. If you take a rectangle and you inherit that into a square, all of a sudden you're adding a condition saying that they have to be equal. So whenever you change the width, I'm going to change the height as well. And if you change the height, I'm going to change the width. So you cannot inherit square from rectangle because you're going to add conditions to it. And the other way around, you cannot go and take a square and inherit that into a rectangle, because all of a sudden you're weakening your precondition, saying that, weakening your postcondition, saying that, oh, it used to be that they had to be the same, but now they're allowed to be whatever. So you cannot inherit the square from rectangle or the other way around. So you need to make sure that you inherit from shape or something like that. That is kind of the only thing I have ever seen as an explanation of Liskovs. And I couldn't get that into my format converter. So how do we handle interfaces and abstract base classes? And that is kind of interesting, or I thought it was interesting. Because it kind of, if I'm not allowed to change things, and I'm not allowed, let's take for example, I'm not allowed to throw a new exception, how do I know when I'm implementing a new interface what exceptions I'm allowed to throw, since I don't know what the original code did, because the original code is an interface? Interfaces don't define what exceptions are thrown, right? And then at one point I mentioned and said, well, Java is really cool because Java can actually define attributes saying that this code will throw these things. So we can define and say you can expect these things to be thrown. And then some Java person jumped me and said, you're stupid, you should never ever do that, and that sucks, and you're dumb. And I said, I'm not a Java developer. I thought it would look cool. And then I showed this again at another time, and that same dude that said that he understood Liskov's the thing at the beginning, he said, this is not a problem. And I went, what are you talking about? Then he went in and he looked at this thing here. Oops, way back. Let Qx be a property provable about objects of X of type T. Provable says that you need to be able to prove this. You can never prove anything against an interface or against an abstract base class or a pure abstract class because they don't exist. And since they are interfaces and abstract base classes that doesn't have any implementation, it cannot be proved, and Liskovs goes out the window. Which basically means if you just stick everything behind an interface, you never have to care about Liskovs. Yes, I did say that, and that was really dumb, I know. You still have to think about it, but it's up to you. You need to document what exceptions are being thrown and things like that. So what are the benefits of Liskovs? Once again, not pulling down your production system would probably be the best benefit that you've got. Because if you don't make these changes, or if you don't break Liskov's principles, you're not going to go ahead and introduce easy to catch bugs either. Because these things will end up failing in production. It might work fine when you're doing some things, but it might fail other things. So by following these guidelines, you're not going to introduce weird exceptions that shouldn't be there, which would have been easy to catch. It also has an interesting point. If we go back to the testing stuff, if you have a bunch of tests and you're creating a new implementation, you should be able to take your new implementation, shove it through all of your unit tests, and your unit tests should never fail for the new class more than potential logic changes. They should never fail because it's not catching an exception. It should never fail because you couldn't set a property and all of that. So the only thing that your test should be showing up as failure when you take the new class and use it in your tests of the old class should be changes that you have made consciously and said it's not going to return 1, it's going to return 2 instead. Those are obviously going to fail. If you do create a new class that goes through all of your unit tests without any failure at all, either you have crappy unit tests, or you have just created a perfect clone of your existing code, which had basically been useless, right? And okay, next one, interface segregation principle. Interface segregation principle is probably one of the easier ones. Definition is clients should not be forced to depend upon interfaces that they do not use. Okay, so who cares if you get more than you've asked for? Because that's basically what he's saying. When I give you something, you shouldn't get more than you ask for. If you go ahead and buy a car and you come into the dealer to pick up your car and you get 2 cars, would you be sad? I wouldn't. I would be kind of happy. It doesn't even need to be a big car. If I went and bought an ice cream and got 2 instead of 1, I would just be very happy. In coding, that's actually not a great solution. So my version of this is basically, if you break your interfaces down into smaller pieces, it has some good benefits. So it basically means that you get more control over what the receiver of the interface can do. So if your interface doesn't have a delete method, it cannot delete stuff. It also means that with smaller interfaces, you're more likely to go and implement them. Because it's really simple to go and implement a little interface with 2 methods. So you're more likely to go and create a new version of that interface than if you get something with 600 methods on it, and then you go, oh, do I need to go and do a new implementation, or should I just go and modify the old one, because that's much easier? Smaller interfaces have better control. So if we look at my code for this, I made some small changes, nothing huge, but I did solve one of my problems using this. So I took my document storage, and I broke my document storage from being a Meyer open close with a base class into using an interface instead. And inside that interface, or in those interfaces, I actually broke it into 2. So I have a get data and a persist document. I broke read and write into 2 things. For the very simple reason that my file document storage is fine because it can read and write, it can implement both interfaces, but my HTTP input retriever can only implement the input retrieving. It cannot persist stuff. So that means that I don't throw an not implemented exception or anything like that. Instead, I go and say, I only support this one thing. I don't support both. Which means that when I use this class, I don't have to go and say, oh, whenever I get one of these document storage things, I need to wrap my storage, my persist logic in a try catch because it might be throwing a not supported exception. Instead, basically I go, can you give me an input retriever? Because I know that anything that implements input retriever is going to support retrieving stuff. And when I need to save something, I want to get a document persister instead because I know that that's going to support persisting stuff. So I get much, much better control by doing that. That is kind of the only thing I had on interface segregation because it's a fairly small thing. I'm going to jump one slide and I'm going to go to this thing here. Benefits. Okay, so let's back up a few years. I like Mark's talk about web forms and things like that. How many of you were working on ASP.NET web forms when they introduced the membership provider system? How many of you loved that system? That is 0, for those of you who can't see. I was working with a CMS tool at that point, and I did a bunch of implementations of that tool or that system. And it basically was a cool idea that they would have a unified system in the ASP.NET web forms that would handle everything that had to do with users. or membership. So basically, it would have support for logging in and logging out and things like that. And you could have these predefined controls, proper Microsoft programming, drag and drop in Visual Studio, and it would add like login boxes and things like that. It was a good idea. The problem was that once you want to implement one of those membership providers saying that I want to support signing into my application, but I want to sign in using this crappy Access database that somebody has used at some point, and it's just an internal system, and I don't want to build something new. I just want to make sure that everyone can log into the system using this old piece of crap database that's already there. If you want to do that, you would go and say, sweet, I need another membership provider for that database, and write some custom code. Problem was that to do this, you would inherit a base class called membership provider. It had somewhere in the neighborhood of 17 to 20 methods that were all virtual. And the way to implement it, if you only wanted to support logging in, you had to implement 3 methods. The rest of them you could just leave as throw not implemented exception, and that was fine. The system was built around the idea of just accepting that you've only implemented parts of it. Because those other 15 methods were things like validating password complexity, validating retry policies, updating user credentials, updating this and that, and all of these other things that weren't actually about logging in. They were about managing users and validating password complexity and things like that. That should obviously have been broken down into smaller interfaces that one interface supported logging in, because that's what I needed. So everybody would implement that. And then if somebody wanted to support password complexity, there would be like an password complexity interface that I could implement to support that feature. So breaking that down would have made my life way, way simpler at that time. And also it would be simpler to write controls for it, because you could basically go in and control and say, is there an password complexity thing available? No. Okay, you don't support password complexity. I'm not going to run that code for you. So we can control a bunch of things by making smaller interfaces. And the final point here is dependency inversion principle, which follows up nicely, because so far we have taken this massive monolith of an application, which is actually not that big, but in your case it might be massive. We've broken it down into small pieces, right? We've made sure that we don't change those pieces. We use them as Legos, and whenever we need something new, we get a new Lego piece and we put it in there instead of changing it. We don't paint the Lego brick. And then we've gone and said we do Liskov, so we don't break her rules when we do new ones. And then we add small interfaces, so we need to make sure that everybody who needs to do something only gets a small interface. This is getting quite tedious, because we're going to be newing up classes here and there and everywhere and all of that. So dependency inversion follows up nicely here and basically says that high-level modules should not depend on low-level modules. They should both depend on abstractions. And abstractions should not depend upon details. Details should depend upon abstractions, right? So basically, nobody should depend on anything. We should all just build abstract stuff, and it just magically works. Doesn't quite work like that. So if we take away that and we add the human readable version of it, it goes, by making sure that classes don't depend on specific implementations, it becomes easier to change stuff. So a simple application here, a simple sample, is I've got my app, and my app, it's a console app. And inside my console app, I go and say var persister equals new persister. Inside of my persister class, I have logic in there that goes to system I/O and does stuff on disk. This now means that anybody that takes a dependency on persister has also taken a dependency for system file I/O. In this case, I've only got a few layers like this, but you might end up with a big graph, and all of a sudden, like 6 levels down into your object graph, somebody is taking a dependency that you don't want to use. But hey, you took a dependency on this class, so this class is going to force you to take a dependency. So this little thing down here is forcing somebody higher up the chain to take a dependency that they might not be interested in doing. How many people do node development? Yep. And that kind of forces your node modules folder to be 200 megs for a very simple project. Kind of. Because we do have all of these massive dependencies all over the place. So if we break it up and make it smaller, you can see in this case, my app only looks at iPersister. And then the iPersister has an implementation called persister, which takes the dependency on iStorage. There is an iStorage implementation called storage, which then uses system IO.disk. or system.io.file. This makes it really easy for me to go and say, oh, by the way, I want to support blob storage instead. Which means that I don't need to change my app at all. And if I want to change the persistor layer, I'll just introduce a new persistor thingy. And if you want to change the storage stuff, I just introduce a new version of iStorage. This is really nice, and it solves a bunch of problems, because now, just because I'm taking a dependency on iPersistor doesn't mean that I'm taking a dependency on anything else. I'm not being forced to dependencies to other stuff. The only problem here is that who is going to be the one that injects that information? Who is the one that defines whether or not it's an X-persistor or the persistor object? And you can do that in multiple ways. I'm going to quickly just show 3 different ways of doing it. There's going to be the my way, the bad way, no, one way, a bad way, and a really good way. But if we start out with manual. So if we open manual here, we'll see that the program is now responsible for newing up everything. So if we look at the format converter, the constructor for format converter, if we go in and look at that, now takes a dependency on iDocument serializer and input parser. There is nothing in here that news anything up. So if I take a dependency on format converter, I am not taking a dependency on any other class. I am taking dependency that this thing wants to have some interfaces, that's fine, but it doesn't take any dependency on any implementation at all. And instead, I'm going to have to go and say, in my program, I have to go and say, I want you to use this serializer here, I want you to use this input parser here, and I want to pass those in here. The other thing I've done is another thing. I've created a little factory thing here. So for storage, as you can see, I'm not actually injecting storage in here. So input retrievers and, document persisters and input retrievers, so my storage stuff, is not being injected. Instead, I have this static class called input retriever, and I have a static class called document persister. If we look at, say, input retriever, it's a static class with a dictionary, static dictionary of type func string bool, input retriever, input retriever. And using this thing, I can register an input retriever and say, if this function here, or this method that you're passing in returns true, I want you to use this implementation here. And then I can call input retriever.for file name, and it looks at my direct dictionary to figure out what to use. So if I go back out here, you'll see here that I'm saying, I want to register an input retriever, and if the file name starts with HTTP, I want you to use this one. If it is a blob storage URL, I want you to use this one, and in all other cases, go ahead and use that one. This now means that if I go into my program, you'll see that when I need to use storage, it is instead saying, I want the format converter here. Instead of having to inject everything, I'm just saying input retriever.for file name, and I get an implementation, and this thing returns an input retriever, which means that I have not taken a dependency on any implementation. I have taken a dependency on an static factory method or static factory class, but I can change around my application. But yes, somebody is newing up the objects. So in this case, it's my program. The other way, if you don't want to do it manually, is that you can go and add something called a service locator, which I used to use a lot when I did WPF development because it simplified some things. But in the case of a service locator, you can see that my format converter takes no parameters at all. Instead, I have something called a service locator, which in this case uses a Unity container, which is an IOC container that hopefully no one in here uses. There's nothing wrong with it, but there are probably faster and better options. But I'm using a Unity container, and I use container.register type. And I tell the container that if somebody asks for an iDocument serializer, give them this version here. If you're asking for an input parser, give them one of these. Then I create something called, in this case, is a Microsoft Practices Service Location, Service Locator, Set Service Locator provider. And that gives me the ability to do the following. Where is my format converter? There it is. it allows me to go inside my class, and instead of inject my dependencies, I go and ask this service locator.current.get instance, so this code here, for an implementation of that interface. And then the service locator figures out what it needs to do. And the cool thing with registering in an IOC container inside of the service locator is that the IOC container figures out anything else that needs to get injected. So if I ask for an iDocument serializer and the implementation for iDocument serializer has another dependency, the IOC container will figure out that dependency as well and get that injected into that thing and basically build the entire graph that's needed. Downside to service locator, like we're doing in this case, is that it's really hard to figure out that you need to configure a service locator before you can use this class. So if I were to compile this and just give you a DLL containing this thing here, you would have no clue that you needed to go ahead and configure a service locator before you could run it. So it becomes this magic box. That's one of the things. The other thing that people don't like about this is that every service or every class that gets access to the service locator can go and ask for any service in the entire system. And I love that argument because then people say, that means that people can go and delete things that they're not allowed to do. And I always come back to who are they? Because if you're working in a team with other developers on a product, and you're afraid to put things in an IOC or a service locator because you're afraid that your teammate is going to pull out your code and start deleting stuff in your database, you have issues. They are not programmatic issues. They are team issues. And also to build on that, your teammates, will probably have the connection string to the database. So they're going to go and kill it anyway. It has some benefits. If you don't have support for dependency injection, if you're doing, for example, WPF development, service location solves a bunch of things that is slightly more complicated to do otherwise. But if we go and look at the last version of this, which is actually using a proper IOC container, like most people would do, which is this thing here, I kind of do the same thing. I use an Unity container, and I register my implementation. So basically, I tell the container for that thing, use this, for that thing, use that. But instead of going and injecting stuff or requesting things inside of my format converter, with the format converter saying, service locator, can you give me XYZ, which is really hard to debug or see. If we look at the format converter, it now once again requests things through the constructor. And what I'm doing here instead is I'm saying, hey, container, can you please go ahead and resolve a format converter for me? IOC container looks at the format converter, looks at the constructor, gets the most complex constructor it can find, finds all of those dependencies, looks into itself to see if it has implementations for those interfaces, creates instances of those classes, and injects those into my format converter. So it figures out the whole dependency tree for me, and also it has support for lifetime management, so it can make sure that your classes are either singleton or they're transient, or in web scope they might be per HTTP request, so you always get the same instance for the same HTTP request, for example. So you've got a bunch of power coming through the IOC container. And the last thing I want to mention, this is one that I've got some feedback that I shouldn't show people, but I think it's pretty cool. Most people have seen IOC containers, and you often do it like this, but you can actually go ahead and configure your IOC container with an external file. So Unity, for example, and I think most of the other IOC containers, has a way of doing it declaratively. So in the case of Unity, I can, inside of my app.config, nope, that one. In my app.config, I can actually put in a Unity configuration in here and tell Unity that here are the different things. So basically, whenever you see one of those in the config, it's supposed to be that type here and so on. And then I can go down here into my container and I can say, for this thing, use this implementation here. For this thing, use this implementation here. So even if I compile this and release the actual exe file, I can have a config file on the side, and I can go and modify the way that the application works by changing an external config file and just restart my application, and all of a sudden I have another implementation. So people go, why would you do that? Simple example. I used to have a client in New Zealand who had very little technical abilities, and they were building a kiosk solution for, this is awesome, taking pictures and videos at bars and publishing them on social media. So you could go in and pay a few dollars and take 3 pictures, and it would print a little picture or a little like postcard size thingy with your pictures and the logo of the bar, and also upload your pictures to your Outlook account, or sorry, your Facebook account. There are issues with this, very much so, but that wasn't my problem. The legal things I don't care about. And also it ended up on your account, so depending on what you uploaded, it was your account that got killed. But the problem with those guys is that they used to have a Canon camera, so they had a DSLR camera sitting inside that kiosk to take good pictures. And they came back to me and said, sorry, but we need another camera. I was in Sweden at that point, and basically said, the SDK doesn't work with the new camera, and Canon has stopped producing the one that we have. So I went ahead and I got the new SDK, built a new implementation, got a DLL file with the implementation that they needed, sent the DLL file down to them, and told them, here is the config change that you need to do, and you can run the same software that you've done all the time, but on the kiosks that have the new camera, add this XML line. On the kiosks that have the old camera, add this XML line. So we went through and actually made it possible for them to convert and change the entire physical implementation of their kiosk with using just a XML config file. We never had to send new exe files or anything like that. Once in a while, a new DLL, but we could support this huge range of different configurations of hardware with just doing XML changes. So they could go in and say, oh, for this, oh, they also do weddings. So for this wedding, we don't have to charge, so we can't pay anything. It'll be free, so in that case, we're going to remove the coin mech on it, so it doesn't have a payment thing. Change this XML line, you're done. So it opens up for some really cool flexibility of being able to change your implementation without actually changing your code in that way. Benefits, kind of what I said, it gives you this flexibility, and it also means that you can change stuff nicely. And only thing you need to keep in mind is whenever you use the keyword new, you're doing it wrong. That's kind of baseline. Things to consider, very simple. Over-engineering premature optimization, that is what we do as developers. This is going to make it worse, because you're going to over-engineer stuff and make it more flexible than it needs to be. It's going to be more readable in every class, but you're not going to know how your application looks until at runtime, because you're going to be building it based on all of these components, which makes it hard to read your application because you're going to have to jump between all of these different classes, but each class is going to be easier to read. Debatability, you are going to be fighting at the lunchroom or in the lunchroom. Don't bring weapons. If you bring weapons, go for guns. Knives is easier to beat. No, actually, civilized discussion, but this is something about opinions. You will have an opinion how it's being done, so you will be debating within the team, how do we do this according to Solid? And the last one is 50 versus 230. My app was 50 lines of code when I started. It was 230 lines when I was done. I added a little bit of functionality, so now I can convert from JSON to JSON. That's very useful. But all in all, the growth is new classes and a bit more separation. But personally, I'd rather have 230 lines of easy-to-read code than 50 lines of hard-to-read code. I think that was it. That was my final slide was just a black slide. Thank you so much for listening. I hope you got something out of it. If you have any questions, I'm sort of out of time, unfortunately, but I will be around the entire day. Just grab me, and if you have any questions, you can ask me questions on Twitter as well, if there's anything. Thank you so much. I'm sorry I'm not Mihai, but I tried my best.